One.
Are you recording? Okay. So hi, my name is Max, and I'll be giving you the story of the Three Kings. Before I start my lesson, I would just like to say that this is the lesson that comes after cubing of a binomial, and is the intro to cubing a ternum. Okay, so here's the lesson. Once upon a time, there were three kings: the Red King, the Blue King, and the Yellow King. Each of them. What is it? Okay, whatever. Each of them were allied to others, and together they and formed an empire. The importance of each king was shown by his size, and each of the king had his very own color, and he dressed all over in that color. Whenever there was a special occasion, all three kings went marching, and they marched in a procession with all of their attendants behind them. So the Red King has 6 attendants. Blue King having his 6 attendants. And the Yellow King having his 6 attendants. Now, there were 6 bodyguards to protect the kings, and they were related to all 3 of the kings in some way. The harmony and order was beautiful to see, but there was something happened. There was beautiful to see, but then something happened. The Blue King, who always had to march in the middle, got tired of being there. He felt he deserved better because he was the first one to assert power and become king. He was the first one to start a dynasty. He was quite different from the Yellow King, who was small and very modest, although he was the initiator of them all. He hated making a big show, but the Blue King wasn't like that. He was not happy being stuck in the middle. So do you know what he did? He sent his 3 attendants to capture 3 closest attendants of the Red King. And as soon as this happened, all the six bodyguards came in to rush to capture the Blue King because it was unacceptable. And to help out, the Yellow King sent his attendants to capture the rest of the Blue King's attendants, and went back to watch the show and not make a big show. And that is the story part of the lesson. But at one point, they entered the decimal system, where the Red King became the hundreds, the Blue King became the tens, and the Yellow King became the units. And so, at this point, we're going to try to name most of these things. Okay? So, just going to finish that. Okay. So, the hundreds having the same length for the length, width, and height would be h cubed, because it's each length or each thing times itself. Okay? And this, having the same square as the Red King, would be h squared, but has the same width as the Blue King, would be h squared t. That. And then this, having the same square, or having still the same square as the Red King, but having the same width as the Yellow king, as the yellow king. So it would be h squared u. Don't zoom up on it. Don't zoom up on this thing. Okay. And this, having the same square as the blue king, would be t squared times h, because it has the same height as the hundreds square, or cube. And this, having the relationship in some odd way, with each of the kings, is multiplied by each of the kings, so it would be hundreds times units times tens. And this, having the same length, length, height, and width of itself, would be t cubed. It also looks like a cube. And it is. This, having the same square as the blue cube, is t squared, but has the same height as the yellow cube, is t squared u. T squared, yes. This, having the same square as the yellow cube, but having the same height as the red cube, is u squared h. And then and last of the yellow attendants, it has the same square as the yellow cube, but has the same height as the blue cube. So this would be squared t, and last, this one still having the same length, width, and height is u cubed. And that is awesome.
Okay. And how are all these kings related again?
Well, they're not related to each other, but the kings are related to each of its attendants and some of the other attendants.
Okay. In terms of their height, width,
Yes.
and depth. Okay. Anything else you want to add in conclusion?
Oh yes, in Harmony E2, we would generally write this on paper by adding them all together, because we're not dividing this by this, and we're not subtracting this by this, or multiplying this by that. We're adding them together, so we write h cubed plus ht squared plus ht squared plus ht squared plus this plus this plus this plus this. But it'd be too long if we just kept writing h squared times t plus h squared times t, so it times h plus h squared times t. So you just write 3, so there's 3 of the same kind, h squared times t. And so that is my lesson.
Okay, and what did you learn from this lesson?
Nothing. The real question is, what did you learn from this lesson?
Not enough, it appears. What was I supposed to learn?
You're supposed to learn something. But yeah.
About
as I said before,
relationships.
this is the intro to cubing a trinomial, and it's the lesson that comes after cubing a binomial. And this is what it looks like.
It all builds up into a
Cube. A big whole cube. And yeah, that is my lesson.
Okay.
Thank you.
Very good, Max.
Alex.
Did you try it, Max?
Yeah.
Does it work?
Yeah, it works.
Yeah? Good.